recording. All right, I'm sorry. All right, so again, this is PALMS 2010, and I am working on chapter number 15, decision analytics, decision analysis actually. All right, so in this chapter, we have to make, if we have to make decisions in terms of uncertainty, so all the time we are making such decisions, and if you have to make decisions under uncertainty, what is the best way, or you can say mathematical way of making a good decision? So every decision or every problem, so the first thing you should have is a problem statement. So in each question, whenever you see a question regarding making a decision, especially from this chapter, you should think about what is the problem statement in the question. So when you're working on your practice problem or homework, you should look for the main problem statement. Second thing, once you have a clear problem statement, you should identify alternatives. So if you have to make a decision, how many alternatives you have, or what are the possibilities, what are the options? So identify alternatives. So the second thing, each alternative should have an outcome. Whatever alternative, for example, if I have to buy a car, I have different options, and then each option is having different, is expensive or cheaper, and then I don't know how many miles I will drive. So this is like, there are different like if I drive a lot, I have to pay more on my lease, but I don't know right now. So it's something like a chance event. So in decision analysis, we call it chance events, and this is all in your textbook. So they have discussed this, everything, and each chance event has an outcome. So there is an outcome, or like if this, so if I choose one alternative, it can have maybe 3 different chances, or three different kinds of possibilities, and then there are 3 different outcomes. For example, in the textbook, there is an example for, there's a housing example. So there's a construction company who wants to develop a building, and they have 3 options. So, and they are saying, if we develop a building, or they're saying condominiums. So if they have to develop condominiums, they have 3 options. Either they should build large condominiums, like 90 apartments, medium, or small. And they are saying, if we build large, we may not see that much demand, or we may see a higher demand, so our profit would be really high. Or if we build a small and there's a large demand, they will lose some money. They can lose some money because they can make, they could have built a bigger one. So they have 3 alternatives. So the point is, they have there are 3 possibilities. So there are D1, construction companies should build small complex, apartment complex, and small means like 30 apartments or something, or small. On the second, they just develop medium complex. Or D3 is, for example, they build a large complex. So they have 3 alternatives. So in each problem statement, we have to look for, first thing we should look for is, what is their their problem. So they are facing the problem is that they want to develop an apartment building, a complex, and they don't know how the future demand will look like. They think if they a building and the demand for the housing is lower in the future, they're going to lose a lot of money because they put a lot of money in building this, and then there is no demand. If they make a small apartment complex and then there's a huge demand, they will regret, why didn't we made a big one and made a lot of money? But there's also a chance they make small and then there's also no demand, so they can actually save money. They did not waste any money. So it's like, this is the problem, and there are three different alternatives, and each one have different uncertainty. So there's a chance event, which is the chance event here based on the textbook example. There are two chance events. One is having a strong demand, and the second one is having a weak demand in the market. So it's like maybe there is no demand in the market, or there's a weak demand, like people are not looking for housing. There can be a recession, there can be anything. So we have to think about what the company should do. And there's also a cost associated with each of the alternative and their outcome, or each of their chance events. So there's an outcome of the cost and the payoff. So another thing the textbook talks about is creating this or putting this scenario in a payoff table. So we can actually put this in a payoff table. And this table is like, I'm just trying to create more space here. So, all right, so the first thing is here we have alternatives. Second is strong demand. And the third one is weak demand. So these are the two possibilities, or the two uncertain events, and these are the alternatives. So I'll list the alternatives here. So this is D1, which is actually if they make a small one, and this is like medium size apartment complex, and D3 is the large complex. So they have three alternatives, and then there is a payoff. So payoff is given in millions, for example. So if they make a small apartment complex and there's a huge strong demand in the market, they will make $8 million. So this amount is in millions. If they make a medium, then they will make, and there's a strong demand, they will make 14 million. So because there are more apartments, and so they will make more money. But if they make a large one and there is a strong demand, they will make 20 million, which is pretty good. But no one knows what is the outcome. So it can be strong, or it can be a weak demand in the future. No one knows exactly what will happen in the future. So if there's a weak demand, if you have developed a small complex, you will actually just make $7 million. And for the medium, you will make $5 million. But if you have a weak demand and you have developed a large complex, then you will be losing $9 million. So it will be a $9 million, and this would be a lot of loss actually. If you think about it, at one stage, if you have, the company will say, okay, we should have made a smaller apartment complex. We have made 8 million, but now it's like paying out of the pocket. It's like we spent all the money on construction, and then also we are paying more because there is no demand. So they will end up losing if they build this. So which should they have? They don't know the future, and the problem is that they want to develop a building complex, apartment complex, and they don't know which is the best option. They don't know in the future there will be a strong demand or a weak demand. If they know the future, they will say, let's create a large complex because the demand would be high. But they don't know, because if they think like there may be no demand or weak demand and they will be paying or they will be losing money, like they will be in a loss of 9 million. So the best way or to approach to tackle this kind of a problem, you can say we can do decision analysis. So decision analysis can be largely or you can say the decision analysis can be this problem can be approached either a probabilistic way, or you can take an approach of a non-probabilistic way. All right, so let's talk about first the non-probabilistic way. So if we don't have any probabilities of the future, or we don't know how the future will look like, we can maybe, we don't know, or there is no data which can tell us how the future look like. The probabilistic way is actually dependent on data, and this is how usually in real life decisions are made. You have past data, or you predict the future based on the past data, and so you say, okay, there's an 80% chance of having a strong demand, or there's a 20% chance of having the weak demand. So you try to use the previous data or some other estimates and try to find the probability of having demand in the future. But if we don't have data and we don't know, we can use this method, which further splits into different options. For example, there is an optimistic method. So all of these things are discussed in detail in the textbook. So there's a conservative approach, and then there is min-max regret. So any questions until now? If you guys have any questions, you can type or you can ask me. I will be able to answer. All right, so talking about probabilistic, optimistic way is like taking the best payoff in each alternative. So this method is like we should look for best payoff. So these are all the payoffs, and what is the best payoff in each of the alternative. For example, here we look for best payoff. For example, here, if I'm here, I will say, okay, for D1, what is the best? So we are looking for, we think it's the market is optimistic, so we will go for the highest a number. We'll say the best payoff from the highest payoff we can get is actually this one when the market is high. So, and for this one is 14 and this one is 20. So we should take the best out of the best. So best of the each strong demand alternatives. And this should be our answer here. So this is the optimistic approach, and we are optimistic that in future demand will be high, which is okay. Okay, we can be optimistic about the future. But then there's a conservative approach, which is like we look for best of the worst possible payoff. So here we have to look for best of the worst possible payoffs. So I'm just trying to clean this area a little bit so we have a better, we have more space. And all right, so we here conservative approach is like look for the best of the worst possible payoff. So we will look for we are thinking that the market would be worse, and we will say okay, 7, 5 is the possibility, or in the future it will be -9. So it's just messed up. So it should be like this, or it should be like this. All right, so we have 3 options for the worst possibilities. So if the worst possibility is that the demand is weak, so we will look for the best possible option. So in this situation, we will pick this number and we'll say the best option is D1. We should go with D1 because it is the highest payoff in the worst market. So this is the conservative thinking, which is pretty straightforward. Then comes the min-max regret, or we can say opportunity loss. So here in min-max, mini-max, it's actually mini-max regret. It's like how much opportunity loss will be there if you haven't chosen the right thing. Like you try to find out if I have chosen the worst option, but how much money I would lose if the strong market has happened or if there's a more demand in the future. It's like finding opportunity loss. So in this one, we try to find the regret and minimize the regret. So our objective is to minimize the regret. Minimize the regret. So this concept is like it's the difference between the payoff associated. So what is regret? Regret is the difference between the payoffs associated with a particular decision alternative and the payoffs associated with the decision that would yield the most desirable payoff for a given state of nature. So what it actually means is that if we have chosen this option, what would happen if this occurs? How much regret we held? We will have a regret of 12 million, for example. Or if we have chosen this option, what would happen if this occurs? We would be very happy that we chose this option. So regret will be 0 at time. So to do this, there are a few steps you can actually find that regret. So to find the regret in this scenario is actually we can build tables, or the textbook also gives us a nice formula to find regret. The formula is like to find regret for ij. So I is row and j is column. For item ij, we have to go payoff. So we is the payoff j and ij. So it's like taking a difference and then taking a mod, which makes it positive. So I will explain this in few steps. Oops, I don't want to do this. I think I just need a bigger thickness. All right, so to find regret, we have to create a regret table. Like, how can we create a regret table? So we have three alternatives, and we have two kinds of demand. There's a strong and there is weak demand in the future. So there's the first alternative, and we have a payoff. So to find the payoff, first time we will take a subtraction of each of these, like column, like this value, column max. So the column max is 20. We are saying if we have done, we are taking 8 minus 20. So this would be equal to 12. So if strong market happens and we have chosen this alternative, our regret is $12 million. We would say strong happened and just made a small complex. Regret is this. Similarly, we can find regret for this one, which would be 14 minus 20, which would be 6. And if we make large condominium and strong market, we have no regret. We are happy. We have no problems at all. Same thing we can do here. So here, if you can see 7 is the payoff if we make and weak market happens 7, and also the 7 is the maximum value. So maximum of this column is 7. So we'll take 7 minus 7 is equals to 0. Actually, no regret. So we decided we should make a small apartment, and actually weak market happened, and then the maximum we can make in a weak market is actually 7. The maximum we can make the profit in a weak market. So a weak market profit, this is -9, this is 5, and this is so the maximum we can make in a weak market is 7. So there's no regret here. In the second option, we will do 7 minus 5 or 5 minus 7, which will be 2. And then there is -9 and -7, which will be equal to 16. Because there's a mod, so it will just make it positive 16. So this is our regret. So this is the regret in this situation, this one, this one, this one. And now in the second stage, our objective is to find we have to select with the minimum of the regret. So we should select in the second step. So for example, this is our first step. So this is our first step done for this method. In the second step, we have to look for maximum regret. So D1, D2, D3. So what is the maximum regret? Maximum regret we can get. So if we choose, so each row, we will look for the maximum value of the row. So each row is the maximum regret. So this is the lowest regret here, and this is the maximum. So I'll put here maximum of the row, and here will be 16, 16. Now the final step would be to find the minimum of the maximum max regret. Like our max regret is minimized. So we are regretted, but it's the minimum regret we can take. And the minimum of these three is actually this number. So the best option based on this method is D2. D2 would be our min max regret. And it makes actually more sense to use this method than a conservative approach or an optimistic approach, because this actually minimizes our regret. So there should be no regret or minimum regret. So this is pretty, this is like first section of the first 15 chapter. This is the approach for non-probabilistic approach, non-probabilistic method. Another one is the expected value approach, which is actually very simple. Expected value is actually average. If you think about it, expected value is also called average. Average, which is also called mean or mean value, which is actually just if there are two values, A and B, is just the sum divided by 2 because the total number of values. If we have 10 values, A1, A2, dot, 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 A10, so we will do, this is the average. In probabilities, we can find expected value of events or total expectation by, we usually call it EX, expected value of even X. And we can say that sum of probabilities of X into actually X. So just to understand a little bit more, we can put like the same, for the same example, maybe we can make our, to explain this better, we can take the same example. We have 3 alternatives and we have the same payoffs for them. So I'm trying to look for the payoffs again. Okay. Yep. So this is the strong market and this is the weak market. So this is 8, this is 14, this is 20, this is 7, this is 5, this is -9. Now we have more information, or we have information like probability of happening a strong market is 0.8 and this 0.2. And usually in decision analysis, we usually assume that one of the two things happen. So the two events, this one or this one, they are mutually exclusive. So one of them, if one of them will happen, the other one will not happen. So this is called mutually exclusive. Or we also have an assumption, a strong assumption that one of them will happen. So it's not like there will be no market and no weak market. There will be something called a medium market. There is no such thing in this problem. So we make our assumptions, and then if a question tells you the probability of a strong market is 0.8, you should actually put that in you should say, okay, the probability of a weak market would be 2 right away, because we know that if there are two events, A and B, they are mutually exclusive and exhaustive, they will add up to 1. So if this is 0.8 and I don't know this, I can calculate as 0.2. So we know from basic probability that all the events add up to 1. So here in this, we can actually find expected value of D1, which will be like using this formula. We will do X is 8 here. So we will do probability of X is of this event is 0.8. So we'll do 0.8 into 8 plus 0.2 into 7, and the 2 expected value of 2 will be equal to 0.8 into 14, 0.2 into 5, same thing, -9. And we can find each of these expected values, and we will know that this is equals to, so this thing comes out 7.8. This thing comes out at 12.2, and this thing comes out 14.2. So if we have to choose the best option based on probabilities, we will go for D3. So this is the best option based on, if we have the knowledge that the chances of having a strong market is 80%, and the chances of getting a loss of 0.9 is only 2%. So we will definitely take this option because the expected value or the expected revenue or expected payoff is actually 14.2, which is higher than both of the other. So this should be our decision in when we have this knowledge. And of course, if this thing changes, this becomes 0.5 and 0.5, the whole equation becomes different. It's, if we both say they are equal to 0.5, 0.5, this is like no information actually. If you say that the occurring of the chance of strong and weak are just equal, it's like telling you, giving you no probability. It's like it doesn't add anything. We will just go back to the same thing. Okay, maybe a better way to do is use minimax regret approach, because it's not telling me anything. It's just they're saying the probability of this and this are just the same. So this is one way to do this. And then we can also do sensitivity analysis, and textbook talks about it, which is pretty much same. Like if you're changing probability, like what I was talking here, like if you're 0.8 and you're 0.2, how about if we are just at 0.7 and 0.3, 0.6 and 0.5, 0.6 and 0.4, how would our alternatives will change? Would we go to D2 and D3 and do 2? So it will be like changing, and how much sensitive our inputs are with the data. Well, actually, in real life, in real data, in real life, we actually predict these numbers. So we do everything. This is pretty basic. When you're actually working with large data and you're actually working with data, you're in data science. All this becomes pretty like you just calculate this in your head. This is like very basic stuff. The harder part is to predict the market, and then anyone can actually tell quickly that what is the best option by doing simple maths. But predicting the probability of future having a strong market is actually the tough part, is actually the hard part. And this usually is done through regression. So in I think chapter 4 or 5, we will learn some techniques called regression, and this has a lot of application. And then you can actually predict how you can make predictions, or we will also do moving averages. So moving averages or forecasting, moving averages and forecasting. Forecast will actually help predict the future, and then you can make these analysis. So in those chapters, the objective is not to find expected value or find these answers, but just to make forecast for this number or something like this. So this is basic overview of chapter number 15. I hope this is helpful. And if you have any question, you can post in the discussion forum or send an email. I will prefer to have it in the discussion forum. All right, thank you. Do you guys have any questions on this whole thing?
No, thank you.
All right, thank you so much. And I will actually post this video online so others can also see this. It may help them. Thank you. Thank you, Wong. I appreciate you came. Thank you so much. Thank you, Sarah.